How often have we heard it said, "That's not logical"? But what is logic, and what does it mean to be logical? You may have heard the word in association with a variety of areas. For example, you may have heard it in mathematics, in computer science, in languages, or in that which encompasses them all, philosophy. Indeed, logic is the language of philosophy. We will look at two broad types of logic: deductive logic and inductive logic. Sometimes these are called formal logic and informal logic. We will focus on deductive logic to start. Imagine that you meet an alien of a species called Gronk. He tells you that all Gronks are green. He also promises to introduce you to his cousin Fred. What conclusions can you draw about cousin Fred? It only takes a moment to realize that Fred must be green. The information you already have makes up what we call the premises, the things taken to be true. In this case, it's that all Gronks are green and that cousin Fred is a Gronk. Indeed, the information in the conclusion is already contained in the premises. If you accept the premises as true, but believe that Fred is not green, then you are wrong. This is not a matter of opinion. Consider a Sudoku game. Each of the rows contains the digits 1 to 9. Each of the columns contains the digits 1 to 9, as do each of the set of 9 squares indicated in bold. These three conditions make up the basic set of premises to play the game. We need to figure out which numbers fit into the boxes as conclusions based on the premises. If we try and place the number 4 as indicated, this violates one of the premises, that within the box the digits 1 to 9 must appear once each. Therefore the 4 cannot be there, and thus the game progresses. Consider again our first deductive argument. All Gronks are green, cousin Fred is a Gronk, therefore Fred is green. Recall our premises are those things we take to be true, and from which we draw the conclusion. Deductive arguments are characterized by the fact that the truth of the premises guarantees the truth of the conclusion. If you accept the premises but do not accept the conclusion, then you are wrong. Let's consider in more detail the idea that all Gronks are green, which makes up the first of our premises. In doing so, we now move into inductive logic. Imagine that we had not met our friendly Gronk, and we did not know that all Gronks were green. We may have to make an observation based on a certain sample that might lead us to generalize that all Gronks are green. We may not have seen them all, but we have seen enough to draw that general conclusion. This does not mean, of course, that some gronks may not be green, just that all the ones we've seen have been. In effect, our argument looks like this. We have seen lots of gronks. These gronks are green. Therefore, all gronks are green. Critically, unlike deductive arguments, the information in the conclusion is not contained in the premises. We have gone beyond the information of which we were sure, and this is characteristic of inductive reasoning, where the truth of the premises does not guarantee the truth of the conclusion. Consider another way in which we might think inductively. Given a human skull, scientists are able to reconstruct to some degree the facial characteristics of its original owner. This is done by matching marks on the skull with potential muscle development. This is the skull of an Australopithecine, an ancient human ancestor. By analogy with the process described before, we should be able to reconstruct the facial features of Australopithecine to some degree of accuracy. The argument goes like this. We can reconstruct modern human facial features from skulls with some accuracy. We have Australopithecine skulls. Therefore, our reconstructions of Australopithecine facial features should have some accuracy. In the case of both our gronk and the Australopithecine, there can be some argument about the conclusions. Are gronks really all green? And do Australopithecines, or did they, really look like that? The fact that there is some inherent uncertainty in our conclusion means we are working inductively. In such cases, we have to consider the strength of our generalization and the fit of our analogy. It is in these circumstances that the process of argumentation can be very beneficial. In summary then, we can consider logic in two forms: deductive logic and inductive logic, sometimes called formal logic and informal logic. What characterizes deductive logic is that the truth of the premises guarantees the truth of the conclusion, whereas in inductive logic, the truth of the premises does not guarantee the truth of the conclusion. To answer our original question, if we saw that all the gronks in our sample were green, and from that drew the conclusion that all gronks were orange, that would be illogical. By the same token, if from the skull of an Australopithecine we drew the conclusion that the living creature looked something like this, that would be illogical.